Hi, I'm making a short video here to demonstrate some software I wrote a long time ago, almost 30 years now. This is the original version of a program called ClayWorks, which is a 3D modeling program. I wrote this version in around 1992 when I was in my second year of A-level into my first and second year of university. This is entirely written in Pascal and assembly. I'd done some programming before this. I'd done a version of modeling software for this on a borrowed Acorn Archimedes, which I borrowed from school. I'd done a bit of programming in BASIC on the spectrums and all that sort of thing when I was much younger. But in between then I was more into my pixel art with my Amiga and D-Paint and all that sort of thing. When I eventually got a PC, which was a little bit after I did this original version, if I show you this, it looked more like this. As you can see, this is more about the pixel art than the programming, but if you went into the edit button there, it would have a very primitive 3D modeling program written in BASIC on the Archimedes, on the Acorn Archimedes. That was basically my learning ground, applying GCSE mathematics to solving the problem of displaying 3D objects. So I knew how to make spheres, I knew how to move points around, but it didn't do much more than that. So when I eventually got a PC and I started at Sixth Form College, I began to learn Turbo Pascal, which is a great language for learning how to program in. I'd say it's a better starting language than BASIC. It allows you to write much more structured code. So back to this is Ball and Pascal. If I open up the main file for the editor and run it, I'm running it from the IDE just to show also that there's a source code here, all of which is available. It's open sourced, and I'll be giving the links in the description. I'll run it. Hopefully it will run reliably. When you run it from the IDE, it does run a little faster, but I have found it to be somewhat less reliable. I have a few theories as to why that is, but I will go into that later. So this is ClayWorks. This is the first version of this software that I wrote with real intent, really wanting to make a proper piece of software. I used what I learned from previous attempts in BASIC to write this system. What I'm going to do whilst I'm talking is try to make a model of an aeroplane. This will be difficult for two reasons. One, I'm not very good at doing this whilst talking, and secondly, my modeling skills aren't as good as you might imagine from somebody who's written 3D modeling software for 30 years. This is largely because when you write software like this, you're very critical of anything you've written yourself or anything you use from anybody else. So I'll be using a piece of software, whether it's this, later versions of this, Blender, or any other 3D modeling program, and I'll be constantly thinking, oh, I could do that better, or that should be better, or that's not quite right, which leads me to then go on a programming journey instead of actually doing the 3D model that I was there to do. So, without further ado, I'm going to start making this model. So, here is where we start. The starting point of this is a sphere. So you can select the number of segments, longitudinal segments and radial segments in your sphere here. I think how far does it go up? Can't quite remember how large this goes. 60. That's generous, but that's a bit big for what we're doing, and it's a bit fiddly to work with. So we'll stick to this one, and first of all select half of them and delete those. So let's get rid of that lot. Then move to select mode and zoom out a little bit. Make sure we're in grid lock to make sure we get nice straight lines, and put it into extrude mode. And I want to have 5 segments in the middle of my mesh there. So there we have fuselage of the aeroplane. Now this isn't going to be anything particularly fancy. You will get much better results using modern software and with somebody who's much better at this describing how to create something. This is just the process of me turning a sphere into some sort of aeroplane that is reasonably convincing as an aeroplane. Like I said, I don't particularly enjoy talking and modeling at the same time, but I'm going to give it a go, so please have patience. So as I do this, I'm going to also be describing what I did to create the software, the processes and the methodology that I used when I was making it. It was a learning process. I was quite young when I wrote this, but I started off with my friends in sixth form college. We were all quite enthusiastic about the new hardware and technology that we were using. We had we'd all grown up with 8-bit and then 16-bit computers, and suddenly we all moved to PCs, particularly as we went to college and they all had PCs, so we started using those and found DOS to be much more accessible as an environment to code in than previous generations. My friends were mostly programmers. I was, like I said, mostly a pixel artist, and I took a computer science course just because I thought it sounded like fun. But I quickly found I got the bug for this, and I got the bug for this largely coming from an artistic side, like wanting to create beautiful images and finding that I could program them quite well. So I did a lot of early stuff in Ball and Pascal, where I would use the Ball and Pascal BGI graphics interface, which was a little programming library similar to maybe SDL or something like that in modern programming world. You could draw lines, you could draw polygons, and all those sort of things, and found that to be quite easy. However, as we moved along, found BGI was actually quite slow. It did the job and allowed you to have an introduction to this sort of thing, but if you tried doing any kind of animation, or if you tried to draw as many points on the screen at the same time, it was too slow to be really useful. So at that point started to look into ways to write an alternative, which was a little tricky without any. This is before the internet was really available to people at home. I think that if you were at university, you wouldn't have had the World Wide Web, but you would have definitely had access to resources. I didn't at this stage, but I had a stroke of luck in that I was walking through Staples one day and I came across this book, which I unashamedly love. Whilst it's not got a lot of character development and the plot is a bit dry, this tome was absolutely fantastic, and this particular one is falling apart, as you can see, because I made a great deal of use of it. And with that, I started to rewrite Ball and Graphics Interface in assembly. This both taught me assembly and graphics programming. It's an introduction to classic line drawing algorithms, Breshman's line drawing algorithm, circle drawing algorithms, all these sort of things that really, for me, introduced concepts like differentiation and all that sort of thing as well for the first time, and really taught me how to do this. And I'm really glad I found this book, and I'm also really glad that Ball and Graphics Interface wasn't very fast, because otherwise I wouldn't have had any need to learn all of that sort of thing, which started me on a journey which led to just about everything else in my career. So with that, I started to write this graphics library and found that we could draw things on the screen much faster, and we could get interactive frame rates and have mostly wireframe graphics, but we could have really nice wireframe models spinning around on the screen, and we were very happy with that. Now, the trouble is, entering those models was really tedious, because without any kind of 3D modeling software, and there were 3D modeling software programs available at that point, 3D Studio existed. I didn't have a copy of it, but I know it existed. That was based in DOS at the time, no 3D Studio Max, it was just 3D Studio. And I thought, well, what we really need is a 3D modeling program. My friend said, don't do that, that will take you forever, that's a silly thing to do. And they were entirely right. This version took me a few years, and all subsequent versions, I suppose, have taken me till now. But it's all the things I learned on that, and all the things I learned through the process of writing this, I'm very thankful for, and wouldn't want to have any other way. So in writing that, both fixed the bugs that were in Ball and Graphics Interface, but used this on a very similar pattern. Mostly it was following the same API style interface, so that it would be a drop-in replacement, at least in the beginning, for Boolean graphics interface. So I had all the line drawing algorithms, all of the polygon drawing algorithms, but then I went a bit further with it as well and introduced Gurag shading and texture mapping on the 256 color version. But for this particular version, this was all 16 color, which was you programmed it in an entirely different way. The 8-bit index color mode, which would be, if you've played Doom or you played Wolfenstein or any other games from that era with low resolution DOS games, they would have been that's the kind of mode that we're talking about. You've got quite a lot of choice of colors, far more than on the Amiga or ST. You've got 256 different colors on screen at the same time. It's not as good as photographic quality. It's basically GIFs. When you see a GIF is that standard. You have a choice of 256 colors. And unfortunately, that is very low resolution, only 320 by either 200 or 240, I believe. And not really, you could write a productivity tool at that resolution. Dpaint use that resolution, but you're quite limited. You haven't got a lot of space for your buttons. So for this, because the vectors are more important, I went for 16 color mode, which allows you to do 640 by 480, which again isn't particularly high resolution, particularly not by today's standard. I think on my mobile phone it would be a tiny little far less than a postage stamp, a little dot in the corner. But it was comparatively high resolution, but at the cost of not very many colors on the screen. In fact, you can see them here, just 16 colors. I think this part does stretch, but it's only just repeating itself. Double click on those, you can change the color, and as you can see, it changes. The colors are shared by the UI and everything else. Did actually have hue, saturation, and value in there. The routines I had for that I still use. This is that code. I converted to C++. That is one thing. RGB to HSV conversion, I think I've modified it a bit over the years, but it's one of those things. You write it once, why do you ever need to write it again? So anyway, back onto this. I'm making this fuselage. So this Boolean graphics interface, I'll go into a little bit more about how the screen is arranged in 16 color mode. It's not as straightforward as your 8-bit color modes, as I talked about before, that Doom would have been using. You have what's called Planar graphics, which is the same as the Atari and ST did, where colors are not defined as 1 pixel equals 1 color. Instead, what you have is something like this, and I'll just bring this picture up. You have each pixel is represented by a single bit and a byte. So a byte will hold 8 pixels. That is a monochrome image. It's a black and white monochrome image, but you've got 4 of those. You've got these 4 bit planes that all look a bit like the final image that you want to see, but none of them would look exactly like it. That's because each of the planes represents a bit of a number, a 4-bit number that goes through all of them. So if you have the first bit plane and the top left pixel is set, and then it's set on all of them, you'd end up with a color index value of 15. If none of them were set, it'd be 0. If the first one was set, it was 1, the second one 2, 4, 8, and then any combinations of those, it's a binary number that is any number between 0 and 15, or 16 different possibilities. So you can see these different bit planes, you can see the different patterns on there. Each one looks slightly different, and the result on the far left there is showing all of the possible colors that you could have. So that's how these were arranged, and that complicates certain kinds of things. Certain kinds of graphics algorithms become quite difficult when you've got to consider this, and become quite slow. So it's very good for writing single color images. So a lot of the things you see in ClayWorks are in fact just single color. So these lines, these dots, the shapes, the text, everything there is a discrete call to a single color thing. There are a few exceptions. I have in here If I go to exit, it'll pop up with this little bitmap image. That's an image painted in dpaint and brought in here. That's quite rare in this. On slower machines, you can actually see it drawing the individual bit planes. It does it. So actually drawing images is a bit more complicated than this. Doing, again, more complicated things beyond that, and I just press exit because I was talking and not concentrating, so start again with the making of the aeroplane. So certain things are a lot more complicated when you do it through here, and I'll go on to talk about that a little bit later. So in this version of the software, it's mostly flat shaded, no shading. Everything is simply like flat shaded polygons. But in the viewer version of the software, it's used 256 color mode, which is too low resolution really to use in the editor. I did have texture mapping and GUI shading and all that sort of thing because it could run pretty performantly. Now there was also a problem with this though. If you look at the VGA graphics card, when you use that comparatively high color mode of 320 by 200, you were in fact using all of the graphics card memory. You didn't have access to any other anything else in that particular mode, but it was in effect only using quarter of the graphics memory. It wasted 3/4 of the graphics card memory. Now the reason it did that, I believe, was because in order to give you a much more usable and simple to use programming interface, where you were saying each byte in the graphics card memory represented a pixel. So if you wanted one color, you send one number to that byte, the next byte would be a different color, and you could quite easily implement all sorts of graphics algorithms using that. But you're wasting 3/4 of your graphics card memory, and this is in a time when you don't have a lot of graphics card memory, so the idea of wasting 3/4 of it is horrifying. There weren't any standard modes on the VGA that you could get to using the built-in functions through the BIOS to set those. It would use all of it. However, some very clever people, and I'm not sure if Michael Abrash might have had something to do with this, but certainly John Carmack did, found a way. I don't know if he invented Modex, but he certainly used it in Doom. That's what this was called. You could do a strange graphics mode that you could set up by sending odd numbers to the graphics card, and that would set it into this particular mode that was you could get 320 by 200 or 240. I can't quite remember which one it was, and you could have all the graphics card memory, so it was all open to you, but at the cost of programmability. You could only access every fourth column at a time, unless you sent an expensive call to the graphics card, which is the same call you would make, I believe, when you were changing bit planes, as ClayWorks is doing. But that was quite difficult to use if you were doing the style of graphics I was doing, which is a scanline rasterizer. If I'm drawing a triangle, you take the corners of each triangle, you work out the slope down the left, you work out the slope down the right, and then you go horizontally. You fill it in horizontally like that, and you can use that to do, you can interpolate not just the position but the texture coordinate or the color and or the normal, and you'd be able to then implement texture mapping, Phong or GUI shading. That's if you're going horizontally. With the mode I'm talking about, Modex, you'd have to go vertically. Now I never got around to doing that, so I never actually wrote a rasterizer for Modex, other than quite a slow one that just repurposed the code that I had. But in Doom, and in Wolfenstein before it, they used what was called it was a raycasting engine, where instead of drawing polygons per se, it was intersecting a ray vertically. They went down vertically and then intersecting that ray with the representation of the model. So as soon as it would hit a wall, it would know which texel column it was on. So that's why you can't look up and have things disappear to a vanishing point in Doom. It was kind of 2.5D, or a way of saying that. But what they could do is just do all of every fourth one in a go. So this expensive switch, they'd only do so many times, 4 times per frame render. So, Doom was very, very quick, and that was that was something obviously I was interested in, but it didn't really fit with what I was doing. So I decided to kind of skip that step and go straight to SVGA. But this particular version of ClayWorks, whilst I did have an SVGA, you can put this into an SVGA mode. I rediscovered whilst looking at the source code. I'd completely forgotten that I'd done this. You could enter this into high resolution or even 256 color modes, but there was another wrinkle that made this Pascal version not really suitable, and again inspired me to later recode the whole thing in C++. And that problem was related to the now famous thing that Bill Gates said a long time ago, which was 640k should be enough for everybody. And it wasn't. It really wasn't. And the problem was you had this strange memory access mode, which goes back to the 286. This program will actually run on a 286, and I'm not sure what percentage of people now remember even what one of those was, but you had the PC 8086 architecture, which has gone all the way from 8086. Was there an 8018? I don't know. But there was a 286 and a 386, and there was quite a jump between those two. The 286 could only do a particular form of memory access, and this might not be really interesting or relevant to anybody who's not a programmer, and it might not even be really interesting or relevant to people who are, but when you have a pointer in memory on a computer, it's basically a number that points to a place in the computer's memory. So if you can imagine, if you've got gigabytes and gigabytes of memory on your computer, each byte of that memory can be addressed by a number. I think with a 32-bit number, you have access to something like 3 gigabytes. So for most 32-bit programs, you have 64-bit programs, obviously much more. But for 32-bit programs, you have 3 gigabytes, which I'm not going to say that's enough for everybody, because that's the same issue, but years on. But back when 386s came out, the 3 gigabytes was obviously that's what you want to be able to access. Now this program, because it's written in Ball and Pascal of the time, could only access memory in the way the 286 did, which was segment offset. You addressed your memory not with a number that's a flat address that says your memory starts at 0, don't try writing to that, bad things will happen, but then stretches all through the addressable space. In fact, you could write to all the low memory addresses, and I did with this software. I'll be reading and writing from very low parts of memory that had special uses, but for another day. But you can't in this write to flat memory. You have to use this segment offset thing. So a segment would be like a block of memory, and then you had fine grained access within that, but only 64 kilobytes. So the screen was like that. The screen was addressed at a place in the hexadecimal number was A000, and then the offset was a segment you were in, and you write to that segment, and that's every pixel on the screen. So that's enough for this low resolution, by today's standards, 640 by 480 16 color, or the various 256 color modes in DOS. But it was if you went any higher than that, you couldn't fit it all into a segment. And I did actually start writing a version of the graphics libraries that could deal with the segments, but it was a pain, and it messed up everything and made everything more complicated. And you really want to be able to just get on with the fun stuff a little, and when you know that the particular technology is outdated, that might sound a bit strange saying all of this is outdated now, obviously, but back then it was you knew the shift was going to happen to this 32-bit addressing, and that was going to be where the future was. So you'd see it a lot. If any of you remember the old DOS programs, you'd have to run something called DOS4GW, and that was the thing to allow you to do this extra flat mode memory addressing. But Ball and Pascal never really got on that train, or at least didn't early enough for me. So that's one of the reasons I abandoned this code base and abandoned Pascal, although I really liked Pascal. And I have to say that even now, seeing how fast this compiles a reasonably big project like this, it was lightning fast even on a 386 back in the day. So when I moved to C++, I was like, oh, okay, this is nice because everybody's using it and it's widely available and cross-platform. But oh my god, was it slow compared to compiling Pascal. I think the major reason for that is preprocessor. I'm sure somebody can tell me I'm wrong in that. But with C++, you've got a thing called a preprocessor, which means that the compiler can never know for sure if a file's going to stay the same. You can always re-include it somewhere else, and it won't look quite the same because you've changed some value. With Pascal, it had a thing called units, which, funnily enough, I believe in the latest. I keep up to date with what the C++ committee people are doing, and a similar system of units, I think, is coming into C++. I think they might be called modules. JavaScript now has these days, and lots of other programming languages too as well. But you find languages that use modules compile a lot quicker. There are ways of getting C++ to compile faster, but I'll talk about that more perhaps when I'm talking about subsequent versions of this software that were written in that. So I'm back to doing this terrible plane model that I'm doing just to demonstrate that this is real software that works. You can use this. You can use ClayWorks online if you like. I have a version I compiled using DOSBox in a web browser, which uses, I believe, WASM as a backend, and it runs a little slow, but you can run this and later versions of ClayWorks in the web browser through that, all the DOS versions. Versions after that, I obviously moved to Windows. I wasn't going to stay in DOS forever. Those unfortunately are harder to emulate or harder to get working. I'll talk more about that in later videos, but the early DOS versions all run pretty lovely. So you can very flexibly just run a whole DOS machine on a web browser now, which would have seemed madness at the time, particularly seeing as the web didn't exist when I wrote this. You had the internet, but you didn't have the World Wide Web. That's how old this is. This is really old. And by extension, that must mean I'm really old. Okay, so moving this along. It's like I said, this isn't gonna shake the world of 3D modeling. This isn't going to be like the most amazing model that you've ever seen, but it doesn't really matter. I'm just trying to demonstrate this older workhorse actually does work. So that's looking a bit more Concordy. There were a few kind of neat little features in here. Let's just put it into hidden line mode. These aren't really hidden lines. What I should have done with this is just drawn polygons in the background to really make it hidden line. It doesn't use anything like a Z buffer. That would have been ridiculous to try and do in this. You wouldn't have been able to fit the Z buffer into that 64K limit. I think I did consider it, but I did know about Z buffers at this point, but it was a no-go due to the nature of this. I believe I had some sort of quad divide. It wasn't smoothing. It wasn't quad smoothing. Yeah, there you go. Didn't smooth the polygons, but that would come in later versions. But I was subdividing polygons, so you have a subdiv modifier there. So that's quite fun. So you can do that, and also you can render it as flat shaded. You can see that I had a problem there, which I later resolved with extrusions that went around the other way. I wasn't getting the winding order right, and therefore some of the polygons disappear. That's a pity. I think that really annoyed me at the time, and it's annoying me again now when I'm looking at it, but all fixed in the later version. So you could do little things like you can apply a color to certain bits of it. So if you want to have a little stripe on your airplane, you could do that. I'm not sure if I'll be able to get this quite neat enough. I improved the selection in later versions as well. There was lots of things I learned from this that went into, in fact, each version of ClayWorks I learned something and move it on to the next. It's been a great environment to try out new ideas, and it's a great testing environment to have a 3D modeling program, because if you're trying to see what's going wrong with something, being able to see it from different angles is really useful. So when I worked in games companies after this, and they've had their own engine, and they haven't really had tools in there to do this sort of thing and to really look at, I found myself a little bit lost, because I was used to having this very visual way of describing what's going on. So if something's going wrong, I can just spin it around and look at it from another angle. I'll talk more about that. I'll talk more about this, how this has gone through each of the jobs that I've had subsequent to this. Didn't have a job when I wrote this. I was too young to have a job. But because of this software, I got a job. So yeah, we'll talk about that. Other than that, well, here we have a very primitive aeroplane. I'm not going to do much more with it. Just talk about a few other little things that are of interest possibly in the program. The user interface here, I modeled the programming interface of this on the Borland, what is it called, TurboVision, which is the IDE that you saw, and we'll go back to when I exit this, which is a text mode IDE, which is actually really good. It's the best text mode windowing system that I've ever used, and I found myself wanting tools written in it, as I still access Unix terminals through the command line. And when you do that, you're limited in the text editor you use. Partly, I don't really want to broach the subject too much, because it's the sort of thing that starts holy wars amongst Unix nerds, and I consider myself a Unix nerd. But you have Vi and you have Emacs. Those are the text editors. But you have to, and I think this is kind of why they're popular, is you have to learn all the keyboard shortcuts. You can't just use them. They're quite opaque. It's quite difficult to figure out how to use. I think Emacs is easier, because it does actually give you a little bar to say what shortcuts are. But that's far too pedestrian for real hardcore nerds. So, but I never really wanted to do that. I was quite happy with Ball and Pascal, which has nice little menus and nice little windowing system. So I'd really like to see that on a Unix terminal. And I haven't really found it yet. One that's that good, that's a really good replacement for all those. But anyway, so I modeled my programming interface for this GUI on that. So if you were to program this and you were familiar with TurboVision, or you can remember it, because that's quite some time ago now. So it was a kind of not a drop-in replacement, but it did the same sort of thing. There was a few things I was quite proud of with this. The solid dragging windows, which does get a bit slower as you drag over complicated models, but you could resize the windows and drag them around, and it was quite smooth. And at the time, Windows 3.1, again, I'm aging myself here, was the version of Windows we're talking about. So, before Windows 95. And that didn't do that. That you could drag an outline, it would actually draw the outline of the window and then redraw it really slowly. So again, I was taking small amount of pride in the fact that my Windows would update really quickly and Microsoft Windows was really slow. So I was like, yes, I've managed to code something that's a lot faster than the big software giant of the day and of today. Obviously, that doesn't apply anymore. I think Windows is really slick now, but back in Windows 3.1 days, I was quite happy with my own little windowing system, my own little 3D modeling program. Anyway, that's been my introduction to this. I will talk about subsequent versions in later videos. I hope somebody's enjoyed this or found some relevance to it. Thank you, and let's just go back to, this is Ball and Pascal, and with Ball and Pascal there, I shall leave you. Goodbye.